Hi children, I hope all of you are doing good. I know that all of you are waiting for this video and some of you were asking, sir, can you teach in Tamil, can you teach in Punjabi, Marathi? Anyway, I will teach in very simple English, so all of you will understand, because I am also not so good in English. So you need not worry about the way of communication. You can WhatsApp your questions or your doubts or your queries, whatever you have, in whatever language you know. You need not worry about it. We will definitely give you a timely reply. Okay, so I will try to solve some typical examples this time, just as an introduction. Okay, so this is one question that appeared in 2023 Neet UG. So if the galvanometer G does not show any deflection in the circuit shown, the value of R is given by. See, my methodology is to solve questions with least number of steps or least calculations. See, if you do calculations, there are chances of getting a wrong answer. If you do not do any calculation, there is no chances of getting a wrong answer. Okay, let us try this method. Okay, now see, the galvanometer shows zero deflection. See, there will be some voltage across this resistor. Okay, and here it will be positive, here it will be negative. See, this resistor with some voltage across it will act just like a cell, a battery, just like a cell, with the positive pole here and negative pole here. Okay, see, a current will be always coming out of the positive pole of a cell. Whatever current comes out of the positive pole, that must return to the negative pole. Okay, in any cell, in any circuit. So see, this cell 2 volt will try to send a current like this, because its positive pole is on the top, positive pole. And I have told you, the voltage across this resistor also will tend to send a current like this. Okay. So this cell and the voltage across this resistor are opposing each other. See, this galvanometer will show zero deflection only if these two are equal. If this is 2 volt, then the voltage across this resistance must be 2 volt. See, if you consider like this, okay, so the total voltage is 10. The voltage across this is 2. So the voltage across this must be 8, because this 10 volt will be dropped, or this 10 volt will appear across this 400 ohm and the unknown resistance. If this is 2, this must be 8. Now see, whatever current, please listen, whatever current comes out of the positive pole of this cell, okay, it will be coming like this. No current is going through the galvanometer because it shows zero deflection. So that current will come like this, okay, and it should return to the negative pole. So whatever current comes out of this 10 volt will circulate, will pass only through these two resistors. Okay, so the same current passes through this 400 and capital R. Okay, so the voltages are, here it is 8 volt and here it is 2 volt. So the voltages are in the ratio 8:2. 8:2 means 4:1. If the resistance, see, if the voltages are in the ratio 4:1, then the resistances must be in the ratio 4:1. Okay, voltage here it is 8, here it is 2. Okay, so the voltages are in the ratio 4:1, resistance also must be in the ratio 4:1. Here it is 400, then here it must be 100. Okay, so the answer is 100 ohm. No calculation, no chances of getting wrong. Okay, see, now I will tell you some more idea about this dividing voltage. Suppose we have got two resistances. say this is 2 ohm and this is 3 ohm. Okay, and these two resistances are connected in series across, say this is equal to again 10 volt. Okay, this 10 volt will be dropped across this 2 ohm and 3 ohm. Suppose the voltage here it is V1 and here it is V2. Okay, same current passes through both the resistors because they are connected in series. Here the voltage is V1 and the resistance is R1. Here the voltage is V2, resistance is R2. Okay, so this will be V1 equal to IR1, and here the voltage V2 will be equal to IR2. So V1 plus V2, the total voltage is 10. V1 divided by V2, this will be this is equal to R1 divided by R2, and this is equal to 2 divided by 3. So the total voltage 10 volt is to be divided in the ratio 2:3. So total voltage 10 volt is to be divided into 2 plus 3, 5 equal parts. 10 volt is to be divided into 5 equal parts, so that each part will be 10 by 5. 10 by 5 means 2 volt. Each part will be 2 volt, of which V1 is equivalent to 2 parts. Okay, so V1 equal to 2 into 10 divided by 5, and V2, see V2 is 3 parts. V2 equal to 3 into 10 divided by 5. See, total voltage V1 plus V2 is 10. That is to be divided in the ratio 2:3. Then you have to divide that total 10 volt into 2 plus 3, 5 equal parts, so that each part will be 10 by 5, of which V1 will be 2 parts. So V1 equal to 2 into 10 by 5, that is 4 volt, and V2 will be 3 into 10 by 5, that is equal to 6 volt. Okay, now see, same thing. Suppose we have got see, this is resistance, say 30 ohm. Okay, and another resistance, say 40 ohm, and it here we have connected, say 35 volt. Okay, see, resistances are in the ratio 30:40 or 3:4. So voltages also must be in the ratio 3:4. So total voltage is 35. It is to be divided in the ratio 3:4. Okay, so here voltage, here it is V1, here it is V2. Okay, so let me write here V1 divided by V2, this is equal to 3/4. Total voltage 35 must be divided in the ratio 3:4, means 3 plus 4, 7 equal parts. 35 by 7, so that each part will be 35 by 7 means 5 volt, of which V1 will be 3 parts. So V1 equal to 3 into 5 means 15 volt. Okay, so V1 equal to 15 volt, and V2 4 parts, 4 into 5, that is V2 equal to 20 volt. V2 equal to 20 volt. Okay, so this 35 will be divided in the ratio here 15 volt, and here it is 20 volt. Okay, now again you come to this question. If this galvanometer shows 0 deflection, here it is 2 volt, then here also it must be 2 volt. The total is 10 volt. If the voltage across this is 2 volt, the voltage across this must be 8 volt. So the voltages are in the ratio 8:2 or 4:1. So the resistances also must be in the ratio 4:1. If it is 400, here it must be 100. Okay, so by simple inspection without doing any calculations, you can straight away mark this 100 ohm. Okay, now children, we have another beautiful, wonderful question. Okay, this also from Neet 2023. Temperature of a gas is minus 50 degrees Celsius. To what temperature the gas should be heated so that the RMS speed is increased by 3 times. Increased by 3 times. Okay. See, what is the expression for RMS speed? I'll write here VRMS. Okay, VRMS. This is equal to, say, I need not write always this suffix RMS, because here we are dealing with this RMS speed only. We do not have this RMS speed, average speed, and most probable speed. We are dealing only with the RMS speed. So let me represent it by V itself. Okay, need not put any suffix. So V equal to root of 3RT divided by capital M, where M is the molar mass, capital R is universal gas constant, and T is the absolute temperature. What is absolute temperature? Any temperature expressed in absolute scale. Means any temperature expressed in Kelvin. It is absolute temperature. Okay. Now the temperature of a gas is minus 50 degrees Celsius initial temperature. Okay, temperature of the gas should be heated. To what temperature should the gas be heated so that RMS speed is increased by 3 times? So here the temperature we are going to vary, accordingly the RMS speed will vary. Okay, so the variables are only the temperature and the RMS speed. All other factors are constants. Okay, so M will not change, 3R will not change. So let us say V equal to, see, all we are considering 2 cases, initial and final. In both the cases, see, this much will remain same, means this much is constant. This equal to and constant can be replaced by proportional to. See, usually when we write V proportional to square root of temperature, when we replace this proportionality by equal to, we will put a constant. So we can do in the reverse order also. This equal to and see, this thing here, it is a constant, can be replaced by proportional to. So V proportional to root T. Or we can say T proportional to V square. Okay, T proportional to V square. See, to what temperature the gas should be heated so that the RMS speed is increased by 3 times. Means initially if it is V, it is increased by 3V, means it becomes 4V. So increased by 3 times means it becomes 4 times. Becomes 4 times. Okay. See, when you write T proportional to V square, you can write T dash represents the final temperature, T initial temperature. This is equal to V dash divided by V. Okay, whole square. It is increased by 3 times means it has become 4 times. So V dash is 4V divided by V, that will be 4. 4 square means it is 16. So T dash equal to 16 times T. Okay, T dash equal to 16 times T, where T is the initial temperature. Now see, the initial temperature T is given as minus 50 degrees Celsius. We have to convert that into absolute temperature. Means it must be in Kelvin. How do you convert Celsius to Kelvin? You have to add 273. Okay, so minus 50 plus 273, or it means 273 minus 50. It is 223. Okay, so the final temperature will be 16 times 223. Okay, right? Now see, this is the final temperature. See, what is the question? See, to what temperature the gas should be heated, means what should be the final temperature. Okay, what should be the final temperature? This must be the final temperature. Okay, this much Kelvin. This much Kelvin. So if the answer is given in Kelvin, it must be this. See, when you multiply these two in the unit position, see, you have to put 6 into 3, that is 18. Okay, 6 into 3, 18. So when you find the product of these two, there must be 8 in the unit position. So if the answer is in Kelvin, it will end with 8. See, there is no, in Kelvin there are only two options, 3097 and 223, and both and the not ending with 8. Okay, if the answer in Kelvin ends with 8, how do you convert that temperature to degree Celsius? You see, to convert degree Celsius to Kelvin, you have to add 273. Okay, in the reverse process, to convert from Kelvin to degree Celsius, you will have to subtract 273. Temperature in Kelvin at unit position, you will get 8. When you subtract 273 from that temperature, in the unit position, you will have to subtract 3 from 8. Means in the answer, if it is in degree Celsius, it must be ending with a 5. Okay. All these thinking you should go through your minds. Okay. Now see, if the answer is in degree Celsius, it must be ending with a 5. See, in degree Celsius there are only two options. One ends with a 9 and the other ends with a 5. Okay. So the answer must be this one. Okay. No chances of getting wrong. You are not doing any calculation. Okay, now suppose you want to calculate this. Okay, 16 times 223 you want to find out. Say, then what you have to do now? This 223 must be 225 minus 2. Okay, 225 minus 2. Okay, it must be like this. See how to find this one. It must be T dash equal to 16 into 225 minus 2, right? 225 minus 2. Okay, you have to find 225 into 16. Double this 225, it will become 450. Again double, okay, it will become 900. So when you multiply this 225 by 4, doubling and doubling, okay, it will become 900. Means you have multiplied by 4. Now you have to multiply it with another 4. This 900 into 4 will become 3600. Okay, so 3600 minus 2 into 16, that will be 32. So you have to find 3600 minus 32. Okay, this will be the answer in Kelvin. Okay, in order to convert this into degree Celsius, you will have to subtract another 273. Okay, another 273. Okay, means this 32 plus 273, what is 270 plus 30? That is 300. Okay, then 3 plus 2, that is 5. Means you have to subtract 3, not 5. From 3600, you will have to subtract 305. Okay, don't subtract it like that. From 3600, you have to subtract 305. First you subtract only 300. Then what do you get? It will be 3300. Now you have to subtract 5 more. So 3300 minus 5, 3295. That is 3295. Okay, now see, we have another question. This is also from Neet 2023. A horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically up with a velocity 4 meters per second. The ball strikes the water surface after 4 seconds. The height of bridge above water surface is. Height of bridge above water surface is. Okay, now see, this is the bridge. Okay, bridge. Now a ball is thrown like this, say with an initial velocity u. Okay, it reaches maximum height and comes down. Okay, now see, you might be using a convention that when a body is moving vertically up, acceleration due to gravity is to be taken as negative, and when body comes down, acceleration due to gravity is to be taken as positive. Okay, then what would be the acceleration due to gravity when a body goes up and then comes down? If you follow that sign convention, like G negative going up, G positive while going down, then you will have to do or solve this question in 2 steps. First, you will have to consider the motion from the bridge to the highest point, then from the highest point to the water. Okay, in two parts. You will have to consider the whole motion. But there is no sign convention like G negative during upward motion and G positive during downward motion. Actually, G, what is G? It is the acceleration due to gravity. Gravity means attraction of the earth. Okay, earth attracts every body towards its center, or the attraction of earth is always vertically downwards, irrespective of the direction of motion. Whether the body is moving upwards or moving downwards, acceleration due to gravity will be downwards. Okay, see, we have studied F equal to ma, of which m is a scalar, no specific direction, no direction. So the direction of acceleration must be along the direction of the force. See, we are talking about acceleration due to gravity, means the attraction of earth. It is always vertically down. So, attraction of earth is vertically down, then the acceleration due to the attraction of the earth, means due to gravity, also must be vertically down. When a body is going up, acceleration due to gravity vertically down. When a body is going down, then also acceleration due to gravity vertically down. So, the acceleration due to gravity throughout the motion, it is directed vertically down. So, acceleration A equal to G, it is directed vertically down throughout the motion. Now, the initial velocity in this case, it is directed vertically up. And displacement S. What is displacement? Displacement is the shortest possible path from the initial to the final position. You need not consider the path followed by the body from the initial to the final position. From where the body has started its motion? From here. Ultimately, where it is reached, see, it is reached at the bottom. Okay, in river. So displacement is shortest path from the initial to the final position. You should not consider the path followed. Okay, so this is the initial position and this is the final position. So displacement will be, okay, like this. It is directed from initial to final position and it is equal to the height of the bridge. So it is h. Okay. And we want to find what? Okay, no, t is given as 4 seconds. 4 seconds. So we have this much data. See, what is the equation connecting all these? It is S equal to ut plus half at square. See, in S equal to ut plus half at square, that S will give you the displacement, not the distance travelled. Okay, here the displacement we have to find out, that is the height of the bridge we have to find out. Now see, there are quantities. See, this quantity is directed vertically down. This is vertically up. This is vertically down. Now there are quantities directed vertically up and also quantities directed vertically down. Of these, upward and downward, one of the directions you have to choose positive. Any direction, that is absolutely your choice. Any direction can be chosen as positive. Only thing is that opposite should be negative. Now see, there are three quantities, okay, acceleration, then initial velocity and displacement. Okay, of these, two quantities are directed vertically down and one quantity is directed vertically up. Let us take the downward direction as positive because two quantities are directed vertically down. Even otherwise you will get the correct answer, nothing wrong. But just for our convenience and comfort, let us take downward direction positive because two quantities are directed vertically down. Okay, then S equal to ut plus half at square I am going to apply. Okay, see this S will be the height of the bridge that is directed vertically down, that I have taken positive. Then the initial velocity u, that is directed vertically up, must be taken as negative. So minus, it's given as u is given as 4 meter second raised minus 1. So minus 4 into time is given as 4 seconds plus half acceleration due to gravity is given as 10 and time is 4. So ut, downward displacement I have taken positive, so downward acceleration due to gravity also should be positive. 4 square is 16, into 10 will be 160, by 2 will be 80, and here it is 4 into 4 16, so 80 minus 16, that is 64. So h equal to 64 meter. Okay, that is the height of the bridge. So in one equation, even if it goes up and then comes down, in one equation, one simple straight equation, you will get the final answer. Okay. Okay, this is another question also from Neet 2023. A bullet from a gun is fired on a rectangular wooden block with velocity u. When bullet travels 24 centimeter through the block along its length horizontally, velocity of bullet becomes u by 3. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. The total length of the block is. Okay, now see, when a body starts from rest and moves with constant acceleration. Okay, see, body starts from rest, means here the velocity is 0 and moves with a constant acceleration. Acceleration constant means velocity changes equally in equal intervals of time. Okay, see, this is also, if you get this idea, this also you can do with no calculation, no writing, nothing. Okay, means this will be, see, this is actually, here I will show you, here the velocity is u, here the velocity is 2u by 3, here the velocity is u by 3, and here the velocity is 0. If the acceleration is constant, velocity changes equally in equal intervals of time. Velocity changes means velocity can increase with time or it can decrease with time. In both cases, we take the acceleration constant if it changes equally in equal intervals of time. See, here the velocity decreases equally in equal intervals of time. Okay, first suppose this interval, see, this interval is t. So during the first t seconds, velocity decreases by u by 3. In the next interval also it will change by the same amount. In the next interval also it changes by the same amount. So in every t seconds, body loses 1/3 of its initial velocity. So how many intervals will be required to come to rest? U by 3, u by 3, u by 3. How many such u by 3s will be there in u? 3. So there will be 3 intervals. Okay, and the ratio of these displacements will be 1:, starting from 0 ends. 1:3:5. 1:3:5. Okay, this is the starting of the block and this is the end of the block. Okay, this is 5 units, this is 3 units, this is 1 unit. This 5 plus 3, 8 units. Okay, when its velocity falls to u by 3, see, when its velocity falls to u by 3, it has traveled 24 centimeter. So 5 plus 3, 8 parts are equivalent to 24. 8 parts are equivalent to 24. So that each part will be 24 by 8. That is equal to 3 centimeter. Okay, each part will be 3 centimeter. So this will be 1 centimeter. This is one part equivalent to 3 centimeter. So here to here 24, then this is 3, so total will be 27. Okay, 27. That is the idea. Okay, then I will tell you how to do this. Okay, right. Now see, when a body starts from rest and moves with a constant acceleration, then ratio of displacements in successive equal intervals of time will be 1:3:5:7 like that. Okay, see, here the velocity is 0. Okay, after a time t, suppose its velocity is increased by v. Okay, after another t, its velocity again increases by v, means it becomes 2v. After one more t, its velocity again increases by v and it becomes 3v. Okay, after one more t, it becomes 4v. Means in every t seconds, velocity increases by v. Then the body is moving with a constant acceleration. Then the ratio of displacements, if it starts from rest, will be 1:3:5:7. Okay, so if this is s displacement, then this will be 3s, this will be 5s, this will be 7s, like that. Okay, ratio will be 1:3:5:7. See, same thing can be applied in the reverse order. See, this is the case when body starts from rest and moves with a constant acceleration. If it comes to rest with a constant deceleration, then ratio of displacements will be 5:3:1 if there are 3 intervals. Ratio of displacements will be 3:1 if there are only 2 intervals. Ratio of displacements will be 7:5:3:1 if there are 4 intervals. Now, suppose a body starts from rest and moves with a constant acceleration. The displacement is s1 during the first 10 seconds and s2 during the next 10 seconds. What is the ratio of displacements? 1:3. So, s1 divided by s2, this is the displacement in first 10 seconds. This is the displacement in next 10 seconds. So, it will be in the ratio 1:3. Okay, so s2 equal to 3s1. This question you might have seen. Now, suppose a body starts from rest and moves with a constant acceleration. Let us consider the case of a freely falling body. When it is released, it starts from rest and moves with a constant acceleration. Ratio of displacement, see, in the first second it covers a displacement g by 2. Next second it covers 3g by 2. Next second it covers 5g by 2. Okay, ratio of displacements are in the ratio of odd numbers starting with 1. It's called Galileo's law of odd numbers. Okay, now see, same thing can be applied in the reverse order for a body coming to rest with a uniform deceleration. Okay, now consider, see, bullet. It loses 50% of its initial velocity after penetrating, say, 6 centimeter. Okay, so here the velocity is u. After penetrating 6 centimeter, it loses half of its velocity, u by 2. Means velocity becomes u by 2. Okay, if it requires a time t for this, the deceleration is assumed to be uniform. Means velocity changes equally in equal time. If it requires t seconds to lose the first half of its velocity, then it will require another t seconds to lose the remaining half. Okay, so in another t seconds its velocity falls to 0. Ratio of displacements will be 3:1. If 3 units equivalent to 6 centimeter, 1 unit will be equivalent to 2 centimeter. Okay, and see, in this given problem, see, the velocity falls to u by 3. Means what they have given, no? See, here, see, this is u by 3. Now see, in this question, see, velocity falls to u by 3. Means here the velocity is u by 3. Okay, here the velocity is u. And when it comes to rest, its velocity is 0. So it has to lose 1 u by 3. Okay, for that, see, to lose this last u by 3, suppose the time required is 2 t. Then it must have elapsed 2 such intervals earlier. Okay, t and t. During this first t, it loses 1/3 of its velocity and becomes 2 u by 3. In the next t seconds, it will lose another u by 3 and becomes u by 3. Okay, in the last t seconds, it will lose the final u by 3. Okay, now see, ratio of displacement starting from 0 ends must be 1:3:5. Okay, so this displacement is, here the displacement is 1, here the displacement is 3, here the displacement is 5. Okay, this is given as 24. This is 24 centimeter. 5 plus 3 8 parts are equivalent to 24. 8 parts are equivalent to 24. So that each part will be 24 by 8, 3. Each part will be 3. So this will be, see, this is actually 15. This is 15. Now let me write here, this is 15 centimeter. Okay, this is 9 centimeter and this is 3 centimeter because each part equal to 3. Here this is equivalent to 3 parts, this is equivalent to 5 parts. So this will be 24 and this will be 3. Total length of the block will be 27 centimeter. Okay, like this all questions. This also you need not see. I have explained all these in order to for you to understand. Otherwise, all these you can do with the mental calculations or by simply inspection. You can simply or quickly reach the final answer. It is 27 centimeter. Okay, hope you all understood. And if you have any doubt, please do not hesitate to contact. You can contact any time, okay, for any question. And see, we will meet again in the next video. Please share this to your friends and tell them also to subscribe the channel. Thank you.